behavior of curves. So I've just drawn a small picture for you, and the way how it works is you see, for example, here you see something like a wave function, and this is called like sine or cosine. And what else do we have? We have something like this. So this is more sort of x to the power of 2 something, maybe minus x to the power of 2 something, just to have a rough impression of what it is. This is something x to the power of 3. And what else do we have? This is a linear function. And this looks like we have a fraction because the function, it says here, then it approaches some kind of limit, some kind of, right? Some number on the y-axis. So there are a lot more of these. I just want to talk about the most important. I just presented to you, and it's good when you talk about the behavior of functions when you know the basic functions like these. There are a lot more like linear functions, and there are also some tricks, and when you practice it you can easily recognize here the y-axis intersection, and you can easily recognize the slope when you have given some scale on the y and x-axis. So basically it's about teaching your eye so that you can recognize what a function does. And when you can realize it very quickly when you write an exam, then you can also easily prove it because you already know, you have in your mind what it should be, what it has to be, what the function does. Then you can quickly prove it. You can create a proof to show it. You can and then solve the exercise. It is also not only when you're asked to talk about the behavior of a curve, it is good to know it, but also when you want to discuss functions. For example, the classic curve discussion, curve sketching, then you need to know, then it's always good when you know in your mind, okay, the function must have a maximum around here or around here, and you know it can only have one maximum, like in this case when you know it's a quadratic function x to the power of 2 something, it has either one minimum or a maximum or something like this, but it certainly is not something like this, right? So you can avoid mistakes by this, and for me it has worked quite well on high school and college to have a trained eye what kind of function you have, and because these are very easy functions, you know, and when you go to college, when you study math for some semesters, then you might get into trouble when you don't know these basic types and you cannot describe more complicated types. So I would suggest just to know these basic types, and I'm also going to explain it in the following clip how it works, and thanks for watching. How about the behavior of curves or the limit? Actually, for this type of exercise, you need to know, you need to have some experience with curves, how they look like. So this is also a part which belongs to curve sketching. And for example, what it means is if you have a function like this, and you see it's approaching 5, this is the function, this is the x-axis, then you see, okay, what does the function do? When we go with x towards infinity, we know, or we see it approaches 5. And also, like as I said, it is useful to have experience with curves, how they look like. For example, a very important function is a parabola. So we know when we have 5x to the power of 2, it looks maybe something similar like this. If we have minus x to the power of 2, we know, okay, it looks maybe something like this. If we have minus x to the power of 2 plus 5, we know it looks most probably something like this. So the thing is, the more you know about these functions, the easier you can get an impression about it, and also the easier you can find mistakes. If you make mistakes, then you can find it very easily by just knowing how the function looks like. So you know, for a parabola, okay, if it's just x to the power of 2, you know it can never become negative. Why is that? Because if you put in minus 1 to the power of 2, of course, will always be something positive. Because minus times minus is always positive, and positive times positive is also always positive. So some other important functions are the group of linear functions, which all look something like this. positive slope or this negative slope, or you can draw any amount you want, and always keep in mind like slope triangle. This is positive slope, positive, negative slope, and this is always the y-axis intercept here. It can also be negative. So this is about linear functions, and there are also functions like exponential function. And there we have 1 for e to the power of x. And another type of function is this one, x to the power of 3, and we know, like, if we have negative, if we put a minus in front of it, then it would look something like this, right? Minus x to the power of 3. So this is about general functions, and maybe depends on the level of your experience. Of course, there are a lot more, like for example sine. This would be sine, and another one is cosine. So depending on the level of experience, you already know, okay, what does the function look about, just about. I mean, you don't have to know it in detail, but just have an impression of it, how it looks like. And to train your eye a little bit, your eyes a little bit to these types of functions. So, and also not only these functions, but when you know how it looks like, just about, you can also say like e to the power of x plus 5 looks probably like this e function, but moved a little bit upwards, right? So, this about experience with curves, how they look like. And now we want to calculate an example, or just show how we can talk about the behavior of curves with the limit. And so we just have a function which is minus 18 plus e to the power of x. And then we see already, okay, it's this famous e function, it's this one, but it's moved downwards because we have minus 18. This is the y-axis intercept. Actually, no, it's not the y-axis intercept, but we know it's minus 18 added to every value of the e function, so we know it's definitely something around minus 18. So it's moved downwards. But how about the minus 18? We're not sure yet, but we will see in a second. So behavior of curves is always about the amount of x towards infinity, and the question is, what does the function do for this assumption? So we have first x towards positive infinity, and second we have x towards minus infinity. And that's what we're going to test. So we have the limit x goes towards positive infinity, and we know it's an e function. And if you know e functions, if you put in very big values for x, then you see f is always getting bigger the bigger x gets. So we say there's no limit. Limit doesn't exist. F goes towards infinity for x towards infinity. And the other direction is x towards minus infinity. And then we just have a look at the function, and then we see, okay, if we insert something negative, minus 10, then we have f minus 10 is minus 18 plus e to the power of minus 10, and to the power of minus 10 we can also write like minus 18 plus 1 divided by e to the power of 10. And then we see the more negative the x gets, the smaller gets this expression. So minus 18 plus something very small, so we can say that the smaller x gets, the more minus negative x gets, the more we approach the minus 18, and we come from the positive side because this is always positive for a negative value, for a negative x, right? But it gets very small. So we approach minus 18. So we have a limit for the y values for x towards minus infinity, but we don't have a limit for f when x goes towards positive infinity. And this is how it works. So basically, this is important. And also important to know about how functions look like in general. And then you can analyze the behavior of curves. So this is how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.